Karma Health. This video is an extension or a second part of the previous videos that we discussed the parasympathetic nervous system. In this video, we will discuss the adrenoceptors. Adrenoceptors are basically the receptors of sympathetic nervous system. And these receptors, they are termed as adrenoceptors because they have the neurotransmitter adrenaline and noradrenaline. So from this adrenaline, this part is taken, and as a result, these receptors are called as adrenoceptors. Let's continue with the classification of these adrenoceptors. We have three main classes: alpha, beta, and dopamine receptors. These are further classified as alpha 1, alpha 2, beta is further classified as beta 1, beta 2, and dopamine, it has 5 subclasses of the receptors ranging from D1 to D5. The understanding of these receptors are very important because they perform a variety of actions in the body. We will start learning the actions of these receptors system wise. So here we have a person and we will go system wise. First we'll discuss the organ eye. In the eye, we have alpha 1 receptors. They are present in the eye, as here we have, this is the iris, and there are some radial muscles that are present alongside the iris. These alpha 1 receptors are present here. What they does that when they are stimulated by their neurotransmitter, adrenaline or noradrenaline, what it does that it causes the contraction of these radial muscles. This contraction, it results in the expansion of the iris. So this pupil, which was of this size previously, it will increase in the size. And this phenomena, it is called as mydriasis. So whenever you give a patient any drug that has a sympathomimetic activity, it will cause mydriasis in the eye. Also, we have some ciliary muscles that are present in the eye, and they're also present there alpha 1 receptors, and their contraction will causes an outflow of the aqueous humor, which will result in the decrease of the pressure in the eye. And this phenomenon is very helpful in the treatment of glaucoma, which we will discuss in our upcoming videos. The next organ that comes after the eyes is the heart, a very important organ, heart and the blood circulation or the vessels. So in the heart, we have beta 1 receptors primarily and beta 2 receptors as well to some extent. But beta 1 receptors, they are the primary receptors of the heart. In the vessels, we have alpha 1 and we have beta 2. Let's start with the heart. Here we have the heart, has the 4 chambers, it has the SA node, it has the walls. So all these receptors, they are present in the SA node and the smooth muscles of the heart. So whenever it is stimulated by the neurotransmitter, which is adrenaline, or it could be noradrenaline, what it does that it produces an increase in the heart rate and an increase in the contractility. The increase in heart rate is known as a positive chronotropic effect. And an increase in the contractility is known as positive inotropic effect. These terms are very important to memorize as they will be used in our books very much. So the net effect of the stimulation of sympathetic nervous system on the heart is an increase in heart rate and an increase in contractility. Now in the vessels, we have alpha 1 as well as beta 2. The stimulation of alpha 1 receptor will cause the contraction, and the stimulation of beta receptors, it will cause relaxation. And these are our vessels. Third important organ is the bronchiolar smooth muscles. These muscles, they are present in our lungs. This is our bronchus. It is divided into two main branches, two main bronchioles, and then here we have our lungs. So in these walls, we have beta 2 receptors. Whenever this is stimulated by the sympathetic neurotransmitters, which are adrenaline and noradrenaline. Whenever it is stimulated by both these neurotransmitters, there is a relaxation of our bronchus. It means that these smooth muscles, they relax upon stimulation by the sympathetic nervous system. The next system is the gut. As I've already explained in my parasympathetic video, that our gut, it has two major anatomical sites, the walls and the sphincters. So this is the sphincter and this is the wall again. So these walls and sphincters, they collectively decide the tone of the gut. We have beta 2 receptors in the walls and we have alpha 1 receptors in the sphincter. So whenever they are stimulated by our neurotransmitter, what happens is that the beta 2 receptors are activated and they causes a relaxation. And when the neurotransmitter, it affects the alpha 1 receptors, it causes contraction. So what will be the net effect? The net effect will be an decrease in the peristaltic or in the gut motility, which is opposing as compared to the parasympathetic nervous system. So we have a decrease in the gut motility overall. Next important organ is the skin. So in the skin, we have two kinds of muscles. We have pilomotor muscles and we have apocrine muscles. These are the two important muscles that are present in the skin. In the pilomotor smooth muscles, we have alpha receptors, and in the apocrine, we have alpha receptors. Both of these receptors, upon stimulation by the sympathetic nervous system, will cause contraction. So the net effect is that there will be goosebumps whenever the patient has a stimulation of the sympathetic nervous system. Next, we have metabolic functions. Sympathetic nervous system, it also has a wide variety of effect on the metabolic functions of a body. So what happens is in the liver is the major metabolic house of the body. So what happens in the liver, that whenever it is stimulated by the sympathetic nervous system, there is gluconeogenesis and glycogenolysis. These two important mechanisms, they occur in the liver as response to the stimulation of the sympathetic nervous system. What is the meaning of gluconeogenesis? Gluco means it is derived from the glucose, neo means new, and genesis means production. So there is production of glucose. Glycogen is derived from the body stores of glycogen. So we have glycogen and lysis is the breakdown. Two effects are happening at the same time, that either new glucose is produced and glycogen is breakdown. So glycogen, it is breakdown into glucose. So overall effect or the net effect of this phenomena is that we have increased glucose in our body. As we know that sympathetic nervous system is basically a stress response. So whenever any stress is stimulated, the glucose production in the body is increased. And the metabolic undercomes the metabolic. There is fat cells as well. And what happens in fat cells is that it initiates the process of glycolysis. Last but not the least, there are kidneys. What happens is that the stimulation by the sympathetic nervous system, we have an increased release of renin. This renin, it produces a wide variety of effects in the body, including the retention of water and fluids and the homeostasis of sodium and water in the body, which we will discuss this topic in some other video. This was all about the sympathetic nervous system and the adrenoceptors. We will have a short recap or a short summary of this again.